Here we are at example 5c from our 1.5 notes. We're looking to find this limit as x approaches 0 from the right side of 3 cotangent of x. And again, anytime we're dealing with trig functions like this, we can go ahead and break that up into a sine and a cosine. So right now we have the limit as x approaches 0 from the right of 3 times. Cotangent is really cosine over sine, so we have cosine of x divided by sine of x. Now let's go ahead and break up this even more. We end up then with the limit as x approaches 0 from the right of 3 times cosine of x over 1 times 1 over the sine of x. So pretty much just breaking these up. So now while we're looking at things, 3 is not going to really give us an issue when we apply that limit. The cosine of x, when it's approaching 0, that's not even really going to give us an issue. So the real issue is this 1 over sine of x, because if you try direct evaluation with him, you'd end up with 1 over the sine of 0 is 0, and that's an undefined statement. So we need to do something with this 1 over sine of x. Well, he's really similar to something that we've seen in our previous notes, where if maybe we have like an x on top divided by sine of x, we have seen that that limit does come out to be 1. And so what we're going to do is do a little bit of foo here with x over x to try and get this x up on top. When we do that, we have the limit then as x approaches 0 from the right side of 3 times the cosine of x over 1 times x over the sine of x times 1 over x. So pretty much we've just taken this guy and thrown him over here, thus leaving a 1 over x. At this point, now we can go ahead and apply our limits to each of these. So for this constant, he just comes out to be 3 again. Any x value you're approaching, doesn't really matter if a constant, it's just that constant. When you apply it to this cosine of x over 1, well, the cosine of 0 is that x value, so it looks like it comes out to be 1 from our unit circle. This limit would again just come out to be 1 by definition. And now we have 1 over 0. Well, that's an undefined statement, but let's see what's happening when you're approaching 0 from the right. Well, as you might recall from our previous notes, 1 over x is a function that looks something like this, where we see that vertical asymptote at 0. And we have on the right side doing something like that. Now notice, as you're approaching 0 from the right side, it's going upwards towards positive infinity. And so as a result, the limit, as x approaches 0 from the right, of 1 over x comes out to be positive infinity. Now when you have 3 times 1 times 1 times infinity, the entire thing will just come out to be positive infinity. So this limit will not exist, but you can at least say where this limit is going toward. All right. Now, again, this example is 5c from our 1.5 set of notes.